All right. Well, welcome back to another edition of our Liftoff webinar series. My name is Joe Steele. I'm the Senior Director of Communications and Legislative Affairs here with Lyft. Thank you very much for taking time to join us today. Today, we are happy to welcome Odyne Systems LLC to speak with us about the work they're doing on electrification systems for medium and heavy duty vehicles. So we're very excited to hear about that work and that project that they have going on. I do want to give you a quick update on Lyft, but first a few housekeeping items. Everyone should be on mute, but if you are not, please go ahead and mute your phones or mute your computers. That would be great, as we are recording this session, so we want to make sure that the background noise is kept at a minimum. Second of all, we will be hosting a Q&A session at the end of the presentation, so please go ahead and use the Q&A function at the Zoom toolbar that we're all very familiar with as we've been going on this virtual and hybrid world over the last 18 months. So I think we all know how to use Zoom, and we all made it here. So please go ahead and submit your questions on the Q&A function. So with that, I think we will get started. We will post this, as mentioned, we are recording this. We'll post this on our website at lift.technology, certainly hopefully tomorrow, definitely by Monday. So you can share it with folks who may be interested, or if you know people who did register and weren't able to attend, you can share it with them there as well. So a few updates on Lyft. We are one of 16 National Manufacturing Innovation Institutes. We are based here in Detroit, and our mission is to drive American manufacturing into the future through technology and talent development. So what do we mean by that? We believe in smarter manufacturing, really looking at manufacturing holistically, because we know that the basis of that is our national security and our economic resiliency. We believe the next region, the next area that tackles the concept of smarter manufacturing first is going to come out ahead. And as a Department of Defense Manufacturing Innovation Institute, we certainly want that to be the United States of America. So smarter manufacturing, I said, we look at the manufacturing sector holistically. That really means the connection of materials, processes, systems, and talent. We're not looking at just the materials. We're not looking at just the process, looking at the entire system and the talent that runs underneath all of those. So we run two programs here at Lyft. First is our technology program, Leading Innovations for Tomorrow. And we also have our talent program, Learning Innovations for Tomorrow. We'll touch on both of those as we move forward. So a little bit on the technology program. Again, connecting materials, processes, systems. You see on your screen are four pillars of technology, starting with integrated computational materials engineering, ICME, running through agile and smarter manufacturing to advanced alloy process development, and multi-material joining. You can see the theme there of materials, processes, and systems that we work on each and every day, both in-house here and across our national ecosystem. And we're glad to have Odyne as part of that national ecosystem. A little bit deeper dive on your screen now. I won't quiz you on that, but just you can see a little bit more of where we work under each of those pillars of technology. On the talent side of the equation, again, it's still about innovation, but this time we're talking about new tools, new pathways, and new venues to provide educational opportunities as it relates to advanced manufacturing. And that really, the basis of that is our Ignite Mastering Manufacturing curriculum, which was developed a number of years ago with funding from the Department of Defense. It's a 3-year program for high school students where they get exposed to the world of advanced manufacturing, from material science to electronics, smarter manufacturing, pneumatics, all the different facets of advanced manufacturing they might run into, just to see, is this something I want to explore and continue down the educational pathway with. So that is available not just in our Lyft Learning Lab that you see in Detroit here, pictured below, that is perched above our high bay facility. So students come in here and they not only take part in that curriculum, but they can look out the windows and see the high bay floor below and see our technicians and our ecosystem technicians working on some of the innovations that I mentioned earlier. But it is available not just here in our learning lab, but it is available right now across the country. I believe we have it in 15 states right now, so very excited to see that roll forward. We're also providing opportunities for jobs that are available right now. With our Lyft Certified program. We offered certification classes in CNC, welding, robotics, industrial technology maintenance here at Lyft and across the country. We are very proud of Operation Next. Operation Next is a certification program that began as a pilot program for our men and women of the military. 6 months prior to leaving active service, we gave them the opportunity to work with the base, Fort Campbell, Kentucky, to give them the opportunity to earn a credential, nationally portable industry recognized credential in CNC, machining, industrial technology maintenance, robotics, welding. And that was so successful, the Department of Defense funded us to expand that program to 9 additional bases, 3 National Guard and Reserve locations, and it's been piloted in industry as well. So it is available to the Michigan National Guard, it is available to the Florida National Guard and Reserve and their spouses. It is about to kick off in Wisconsin for the National Guard and Reserve and their spouses. And we're also piloting it here for small and medium-sized companies, as I mentioned, in Detroit and Pittsburgh as a part of the coronavirus recovery effort. So I mentioned Lyft is a nonprofit 501c3 based here in Detroit. We're a membership-based organization. Thank you, Odyne, for your membership. So what do you get as a Lyft member? Well, all of the things you see on your screen here. We are a trusted advisor, giving you the best advice that we can, that our ecosystem can, and how to make that transition towards a smarter manufacturing future. We're a technology accelerator. We mentioned that a little bit earlier. A technology showcase. If you have not been to our facility in Detroit, I encourage you to do so. 100,000 square foot facility here with $50 million plus of equipment that our member companies can come in and use. We really call it a showcase and a sandbox because it's showcasing the art of the possible, but we're really sandboxing and prototyping as we speak today. Connector and convener. That's why we're all here today. So thank you very much for taking the time to join us. We're also a talent developer. Talked about that a little bit. And finally, we are a government partner. Working with the federal government can be unwieldy, can be overwhelming, particularly for small and medium-sized companies. And I know Odyne has experience there, but we like to be that conduit to help companies get involved, to bring those ideas to the warfighter, as well as to the marketplace. So that is Lyft in a nutshell. I encourage you to visit us on our website, lyft.technology, to learn a little bit more. You can reach out to us via email or on the phone or through the website as well. And encourage you to follow us on our social channels to keep updated on what we have going on. So that is our Lyft in a nutshell. I know you didn't come here for that. You came here to hear from Odyne. So I'm going to turn it over to John Petrus and Joe Dallin to give us an update on the electrification of heavy duty vehicles and the benefits thereof. So John and Joe, I'm going to stop sharing and the show is yours.
Great, thanks, Joe. While we get set up here, I'll get started here. John Petrus is going to be joining us. He is our principal investigator. As Joe mentioned, Odyne is a member of Lyft. We've had a very good experience with Lyft. We have ongoing work with them with the U.S. Department of Defense. Leonard Lincoln, our director of sales, is also in the audience. So there is Q&A later. He might be able to assist. So with that, Odyne Systems, we focus on plug-in hybrid electric vehicle systems, and our technology is available today. I'm going to go through a little bit of an overview of Odyne and the market before John really gets into a lot of the details. Okay. Next slide, John, if you could. Great. Next slide. Thanks. Okay, so just some background on Odyne. We've actually been working on this for quite a long time. The company really started working on us back in 2007. Back then, we were part of what's called Duco. We were one of the largest final stage manufacturers for utility trucks for Terex in the country, and our customers were looking for ways to reduce fuel consumption and emissions. So we started way back in 2007 on plug-in hybrid and idle reduction systems. In 2009, the company was spun out. It's a separate independent operating company. Along the way, we were fortunate to develop a strong relationship with Allison Transmission. We'll talk a little bit about them. Allison is the world's largest manufacturer of fully automatic transmissions for medium and heavy duty vehicles. They're one of the largest, well, they are the largest provider of transmissions for the military on their tactical vehicles. Our system is exclusively approved and endorsed by Allison, which means that we retain the warranty of the transmission. So when we're going through today, you'll be able to understand that we are integrated and work closely with them. We've got systems in over 70 fleets, over 60 patents that are been granted or pending. So we've got a lot of experience here, and we really look forward to your questions at the end of the presentation. So with that, just to get a common understanding of trucks, where some people in the audience might not understand a little bit about the truck industry here. Typically, it's divided into weight classes, and you'll see in the top there's class 1 through 3, which are typically lighter trucks. There's a lot of those out there, over 11 million. And then there's trucks 4 through 8. Those are class 4 through 8 trucks. Those are 14,000 pounds or greater. And those trucks typically consume a lot of fuel, a lot of emissions, as we'll see. And those are the trucks that we're going to be talking about today that are in that 14,000 pound and greater gross vehicle weight rating. Okay, next. So just to put this in perspective, there's a lot of medium and heavy duty trucks out there, but you have to put it in perspective versus small trucks. There's, like I said, about over 11 million small trucks. Those are 1 through 3. Really only 5% of overall truck volume is in the medium and heavy duty truck sector. And that's divided between a lot of weight classes and a lot of applications, as we'll go through today. What we're going to focus on is that class 4 through 8 straight trucks. Those are typically what's called vocational trucks. Those are trucks that will drive, and sometimes, and many times, probably 50% of them, will need some kind of energy at the work site, or some type of work they'll do while the vehicle is stationary. So we'll focus on that today. And that's an addressable market of about 330,000 vehicles per year. And Allison Transmission is the largest manufacturer of transmissions within that sector. Allison itself produces over 220,000 transmissions, and many of them are in these sectors, class 4 through 8. So one of the big characteristics of class 4 through 8 trucks is that it's very high fuel consumption. So although they make only 5% of the overall truck volume annually, they actually consume 20% of the energy that's needed for the transportation sector. So that's one of the big reasons that trucks are so important as we're taking a look at how to reduce fuel consumption and GHG emissions. The other big challenge that trucks have had historically is that they really lag improvements in fuel efficiency. This chart here is from the University of Michigan, and it takes a look at historically, how mile per gallon improvements worked out for cars, light trucks, and medium and heavy duty. And you'll see that it's really been flat for many years. I took a look at the U.S. Energy Information Administration, presented some information here, and it shows that there's really quite modest increases. I think the country, my guess is, if it wants to hit the greenhouse gas, goals, it's going to need much higher improvements in efficiency. That really creates a tipping point for electrification in the medium and heavy duty truck industry. One of the other big factors here is the government is starting to work on regulations to improve efficiency. That includes the phase 2 greenhouse gas regulations, which are now in place. They go through 2027. And then you have progressive states like California that obviously are pushing even harder, where they'll be mandating electrification for some of the sectors. So kind of looking forward here at full electrification versus other types of electrification, I just wanted to point this out that the, Bloomberg has a forecasting portion of its business. And on the right side there, you'll see the medium and heavy duty commercial lines, the yellow and green lines. Unfortunately, there's really a relatively slow uptake in full electrification expected globally. And go to the next one here. There's a lot of considerations really to probably attribute to the likely slow adoption of full electric vehicles in the medium and heavy duty vehicle space. Currently, in the near term, you've got acquisition cost challenges, limited range, which can be a big deal if you run a municipality or maybe a utility that has to help others in a storm where you have to travel long distances, and when you arrive, the grid's down. The grid recharge, which could be a big challenge, especially for utilities if you have a grid size outage like we had in Texas that could last for a long time. The infrastructure challenges are very significant for full electrification. I think hopefully they'll be worked out over time, but it will take time. The very heavy, so medium and heavy duty trucks that have full electrification sometimes require, well over 400 kilowatt hours with batteries, which really limit the payload. On top of that, they're very new, so you have unknown resale, durability, and long-term parts availability. So I think there definitely will be a strong increase, but it will take quite a long time for, in my view, full electrification of the medium and heavy duty truck sector. One of the other things to kind of keep in mind here as we move forward is that the truck market is decentralized, meaning that multiple manufacturers build trucks, and they have to work together in order to get the final product to the end user. That's significantly different from light duty. So you've got engine manufacturers like Cummins, which will provide the same engine basically to Freightliner, Navistar, PACCAR, and others. That's unlike a light duty where they'll build their own engine. The body manufacturers next get this chassis. It's, once the PACCARs of the world, being like Kenworth and Peterbilt, once they're done with their vehicle, it goes to a body manufacturer. Well, they'll customize it further, and finally it goes on to the end user. So that go-to-market strategy is significantly different in the medium and heavy duty space versus light duty. Okay. So to summarize this before we get over to John here, is you want to compare, and you could post the next one there, John, is that if you compare the light duty and the what I'll call vocational trucks, those are those straight trucks we talked about, roughly 330,000 of those. There's a lot of modification that takes place that doesn't take place for light duty trucks. So any electrification solution should really accommodate that change, that difference. They're built in relatively low volumes. As an example, that RAV4 shown down there's over 400,000 of those, that one vehicle sold annually. That exceeds the medium and heavy duty straight trucks produced, all of them produced in the United States. So you've got lower volumes, many applications, got horizontal integration, as I talked about, where multiple vendors provide parts to different manufacturers. And probably most important here as we move on is that the truck has both driving and worksite fuel efficiency typically to be concerned about. So the overall efficiency of the truck will depend upon the duty cycle, and we'll be talking a lot about that today. So with that, John will be taking the rest here.
All right, can you hear me?
Yep.
All right. So I'm gonna take us home, hopefully quickly. All right, so we're gonna focus on vocational or old school work truck applications.
Continuing on here, so there's about 175,000 powered takeoffs sold annually, and those powered takeoffs provide power for equipment on the truck. And so you'll see a lot of different applications which are shown here on the pictures. And these are all applications that Odyne is actually electrified. So John, you can go to the next one there. So with that, we've got a variety of different powered takeoffs. Like John was starting to say, there's about, it's over 100,000 powered takeoffs sold annually. And that's the device that takes the power from the engine and actually moves hydraulic pumps and compressors and other devices which help to move equipment on trucks. And right now what goes on is that those trucks idle for hours at a time with, let's say, a 300 horsepower engine, and they move a hydraulic pump perhaps to move a crane, and that really only needs about 20 horsepower of power to operate. So there's a lot of inefficiency and wasted fuel and also emissions that are generated in the power takeoff mode. Next. And I did want to mention that also applications like export power, which is where you replace a generator, and also refrigeration are also great applications for electrification. So with this diagram here, we're showing actually telematics data on an actual vehicle. And we at Odyne call this the V chart, where you'll see the battery discharge over the course of the day. And so there's a lot of different parts of the day that cause that discharge of power. Some of it's driving. As I mentioned, Odyne provides propulsion, helping to move the truck along with the engine when it's driving, so it depletes the battery. Then you also have uses for idle reduction, and then times when the vehicle actually has to move equipment.
This is what we used to think that the typical day looked like. But we did work with the Department of Energy, with the National Renewable Energy Lab. We put telematics on 119 vehicles, 5 different applications, over 1 year of high-speed telematics. And what we saw, and every little bubble in that chart you see there is a different day. There's over 15,000 vehicle days different. And basically what we learned is half the energy is consumed at the job site. Am I still doing good? Yep. Up to 90% of NOx production is created at the job site. And while we can look at average, and this is what differentiates from transport and cars, our average truck on the average day is 26 miles and 4 hours of job site work. But what we also learned and have been publishing and communicating is every day is different. These are other days. They're not V charts. The one on the upper left is a day in the life of a bucket truck. Color coding this green here says it stopped home for lunch and recharge. A lot of red, a lot of driving, a little bit of work. This other one started about 9 in the morning and worked till midnight with work and driving. This panel van pretty much drove just a little bit that day and worked almost the whole day, came home and plugged in. And over in the lower left, just a typical medium aerial 1 month. Even its own days are very different. Some are very V and a lot of work. Others are a little work. Others are almost no work. Our market, truck to truck, fleet to fleet, is different. So, but one thing in common is work trucks work. Most people we work with think about the bucket truck. But there are many hydraulic applications, from buckets to diggers to even tanker trucks. We also work in pneumatic systems. A lot of the utilities have a lot of need for pneumatics, whether it's jackhammers or underground cable work. And another one that most people don't think of is pure electronic. A lot of these trucks have generators. We can export up to 12 kilowatts of exportable power. Some of our trucks, actually our fastest growing market, don't even do hydraulics or pneumatics. They get to a work site like that panel van and they work electronically for the day.
So with that, the trucks are, work trucks that both drive and operate at the work site are very inefficient. They're very slow, meaning that the acceleration typically isn't sufficient, or let's say not as much as the operators would like, very noisy, and very expensive because they idle a lot. There's a lot of maintenance, and sometimes with the emission system, it doesn't respond well to idling. So which means that there's a really big opportunity for electrification of this mode of operation, especially where trucks are working at the work site. Okay, next. All right, so this is actually a really interesting chart. This is based upon work that the National Renewable Energy Lab did, where they tested Odyne's system in Golden, Colorado. So they compared it to how a typical truck works with a power takeoff. On the left side, you'll see the grams per hour in NOx. And so the lower the number, the better. The conventional PTO, you'll see with the green arrow pointing to it, that shows there's extremely high NOx output, 10 times as much as typical during a driving operation with the truck. And so that was something new they found. And that was because actually the catalyst gets cold when the truck is under low load, under power takeoff, and that engine is operating for many hours. And all of a sudden it needs a surge of power to move a boom or move the hydraulic system. And that sudden surge of power creates a lot of NOx. And so there's a huge benefit to turning off the power takeoff mode environmentally in the reduction of NOx, which is shown on the right side with a 90% reduction in NOx. The other big interesting thing is that with the Odyne system, we have the ability to quickly recharge the battery. So if you do go out into the field and your battery is fully depleted, our engine will kick on automatically. It will be under load. It will recharge the battery while continuing to operate the hydraulics and everything on the truck without any interruption. Then it will turn off again. So even in that charge sustaining mode, you still get extremely low NOx output, which is shown it's actually much lower than idle.
The other challenges are who's going to provide the solution. OEMs, the chassis manufacturers, they're providing multi-use chassis, and realistically, EPA, California, all those are pushing them toward increasing their driving fuel efficiency and reducing their driving emissions. And they're very focused between the engine and the chassis manufacturers on that, and the volumes that are in over the road and transport. Go to the other end, the upfitters, they have a narrow focus. They have low volumes generally. They don't have the R&D expense dollars available to go into electrification. And that's where we fall in. We are an intermediate stage manufacturer or a system/kit supplier right in the middle of the whole ecosystem. We work on electrification of vocational vehicles. That's all we do. So let's talk about that. This is our solution. It's a modular solution. It's bolt-on pieces that provide the electrification in between the chassis being built and the rest of the truck being built. The core of that is our drive system. If you look over on the right, the PTO, power takeoff, is standard use in most of these applications. The final stage manufacturers are used to that. What we do is we slip our motor in between the PTO and the pump. And if you think about it, through the PTO, we are directly connected to the crankshaft. It's no different than splitting the transmission and putting a motor in line there. We're just bolt on and coming off the side. So we provide the hybrid power through the PTO port. We are, again, working directly with Allison. We're approved. We've worked with them on some communication strategies through the control modules. We can provide hybrid assist and regenerative braking, just like if you stuck a motor generator in that drivetrain. And we provide the all-electric job site power. We didn't do this on our own. Since Joe formed the company in 2009, 11, maybe more projects have supplied over $32 million in development support. Joe mentioned our Department of Energy NREL work, but this comes from many areas. In the private sector, we've worked with nonprofits. Lyft is one of the ones we're currently working on with. That's why we're here. We've also worked with the Electric Power Research Institute, which services the utility industry, CalStart, which promotes green energy. We've done a lot of work with Southern Cal Edison. We've done work with Commonwealth Edison in Chicago. Publicly, we work with Department of Energy. Currently, we're working with the Department of Defense. We've worked with the CEC, and a very powerful person, or group are the air quality management districts in California. And we've done a lot of work with the South Coast, which is services the general LA area. And I've had, because I'm a geek, I've had a lot of fun working with the National Renewable Energy Lab, or NREL, and Oak Ridge Lab, and they've participated with us on many of our DOE projects.
This slide here shows the 2021 system, our most recent system, and the really improvements we've made, and this is also with prior work with Lyft, is that we are able to modularize this system. So it's very easy to, to actually install on a truck. These modules have the battery system, the power electronics. It's modular so that we can add additional battery energy if the application requires that. We've got export power. And as John just showed, we have the ability to put power in and out of the transmission to improve propulsion, driving fuel efficiency.
The other section I've talked about a bit is our bolt-on drive system and generator system. It's a standard PTO. We don't modify the Allison transmission. We slide our motor generator in here, slip it in, and then the equipment supplier, if we're doing equipment, supplies a pump or compressor and bolts onto the back of our motor. As Joe started alluding to, there's a lot of other aspects about electrification. One of our big keys is our exportable power. We can export 6 kilowatts, put 2 of these on, export 12 kilowatts. We haven't been asked to. We can go higher than that. Don't forget that the truck is still sitting there with the engine off. So we back support the chassis and the batteries with 4 kilowatts of 12 volt DC to DC, so that the 12 volt lights, the radios, all that kind of stuff can still work in the chassis. And don't forget the worker. We've got fuel fired auxiliary heat and 350 volt air conditioning to make sure that worker wants to turn off the truck and use our system. Performance. Again, we're mostly through our DOE projects, working with NREL. We've taken those telematics, we've run our trucks across their chassis dyno, combining the duty cycles with the chassis results. It shows time and time again that on typical work truck duty cycles, we can save 50% of the fuel. Greenhouse gases, CO2 go hand in hand with that at 50%, and NOx, because of the inefficiency of NOx abatement systems at low idle, we can save up to 80% during the typical workday. So our benefits: fuel use, greenhouse gas down, NOx down. The workers that we talk to, their favorite part is the noise is gone. They can work in their work environment, and also the people living in the house where they're working, they can work in their work environment without the diesel noise. And they don't just idle, they go to high idle and they make a lot of noise. Engine maintenance is down. First of all, because there's not so much idle time crudding up the emissions control systems. There's less engine hours by almost 50%. And again, with regenerative braking, we're actually taking some of the maintenance out of the brake on these work trucks. So the other benefit is our market integration. We're a system supplier. We are currently operating on all these pictured varieties of trucks, from buckets to tankers to bookmobiles, actually. We've got a whole line going with bookmobiles. And we are chassis agnostic. Our modular system will fit on most of the regularly used chassis, as long as they contain an Allison transmission, which 99.9% of them do. And we've worked with many equipment manufacturers. Because they can put their pump or compressor right on the back of our motor, we can integrate just about anyone. So what's next? Well, we're going to expand our footprint. This little box is where we started. We sprung out of a utility company. We did bucket trucks, digger derricks, and some compressors. And this chart, although it's hard to read, you can get the download and look at it, is really hydraulic trucks. And on the y-axis is the power needed to do the stationary work, and the x-axis is hours per year. And we started in this little box. Number 4 is actually the utility market. But since then, and here are just a few of our latest applications. I showed you the picture. Just in the last couple of years, we're starting to launch a very high load material handler. It's got a higher power pump. We're supplying a larger e-motor. The rest of the system's the same. And Joe mentioned, I didn't squeeze it into. Mostly what we modify is our control systems. Our controls, it's all the same basics, and we adjust gains and stuff like that to handle what changes with the application. But this material handler bumped us up in available power. Refuse. A city came to us and said, we just want hybrid drive. We want increased fuel economy for our refuse trucks. And we've just launched a group of refuse trucks where we're only doing hybrid drive. Yeah, we want to spring into the rest of the hydraulics, but we did what they asked. This street sweeper was really interesting. A company who makes this came to us, and we integrated what's normally our stationary work. We're now doing hydraulics while the street sweeper's driving. We provide charge while drive. We're greatly increasing their fuel economy because they're not driving all the hydraulics that run the street sweeper. We're doing that, but still it's primarily a plug-in hybrid electric vehicle. We're just taking care of all the work, whereas in a car, they're taking care of the driving in PHEVs. And we had a company come to us that wanted to do rail maintenance in tunnels. And we sprung a derivative off where we're doing all electric creep right now. Same input through the PTO in the tunnel, engine off, and we're creeping the vehicle. So where are we going? We're taking our core. It's a very flexible core, and we're expanding outward to markets and new power capabilities. And there's our material handler. It was just back from the ACT Expo show. That's cool. Here's us testing it at our location. That's a big sucker. It lifts about 1.5 tons of drywall per load. It gets to a site. It and maybe another truck is just full of drywall, and they put it in 3rd-story windows or wherever they have to. That's our latest application. But other things, and where we're primarily working with Lyft, is if you look at the DoD non-tactical applications, except for a couple things that we don't work, it's very similar to what we already do. They have dump, forestry, maintenance. They have refrigerated, which we're looking into with our export power. They have wreckers and carriers. We're working with Lyft to see if we can get into the DoD side. Done some investigations. The total DoD fleet is about 55,000 vehicles of medium and heavy duty vehicle. And as we look at the breakdown, so many of them are what we already do. So that's, trying to expand into the government market. But why stop there? Working with Lyft to look at dual use technology.
So, yeah. So as John was just saying here, we are working with Lyft to take a look at even the use of our technology on tactical vehicles. Tactical vehicles are really very well suited to this type of technology because they typically want silent watch. They have a need for a lot of energy when they operate, especially when they're stationary. Not just hydraulics, which might be a small portion, but electrical loads. So since we can export power from our battery system with the engine off, we're well situated to provide that for the military.
Truck electrification is available today. Can, provide improved fuel economy, reduced emissions, quiet stationary operation. Workers say they like the improved acceleration. We really focus on that. Forget hydraulics. We can provide exportable power, improved maintenance. And key to our solution is we are not changing the truck. The truck, and didn't get into all the details, but if you run out of battery, we can keep the work going and charge at the same time. If there's ever a hybrid issue, the truck can still drive the hydraulics straight through the PTO. We are a kit or an intermediate stage supplier, or we can even go in and retrofit. And there are many, many applications. So why work with Odyne? All right, here's the sales pitch. I'm not the sales guy. Leonard's our silent partner here, but we've been doing this for a while. Got over 10 years. You've seen the diversity. We're working directly with the power takeoff of the Allison transmission. We have patents Joe has a lot of them, but we have patents all over the place. There's a modular system. We're expanding. We're looking at higher exportable power with Lyft and the DoD to see if they're going to be interested in. Looking at the military needs, commercial, looking toward military, dual use. I'll say we can do it all. So if you want to get involved, we're always interested in discussing technology, components, projects, collaborations, research. I'm the geeky one. But integration, new customers, new opportunities. We want to keep expanding. And so, thank you. High-level questions go to Joe. Sales questions go to Leonard, who's been just listening in and taking notes. And geeky project stuff can go to me. And I'll turn it over to Mr. Steele.
Hey, great. Thank you. Thank you, Joe and John, for that. So thank you very much for the presentation. A lot of good stuff in there. And again, if you do have questions, please go ahead and use the chat function. I'm glad you mentioned, or the Q&A function. I'm glad you mentioned, gentlemen, that the dual use technology, because that's certainly something that we focus on here at Lyft, and it makes perfect sense as to why you are involved with us to look at that technology that's available both for use on the commercial market as well as potentially in the DoD space. But I wanted to ask, you talked about a lot of different industries or types of trucks where this technology would be useful. Is there one, which is the largest, I guess? Is there one gaping hole in there, whether it's for municipals or for a particular industry where this is most needed?
I can take that, John. So, yeah, where it's most needed right now is the benefits. While we have very good driving fuel efficiency benefits, the biggest problem really is the operation of vehicles when they're stationary, needing power. So that typically does include utilities, municipalities, certain contractors that work at job sites where the construction activities are going on. So those segments are typically the biggest ones and the ones that need the most help. There's also, I think in the future here, TRUs, transportation refrigeration units, will be a big market as there's new regulations going on to try to electrify those. We're actually our system could be a very good fit for those applications.
Awesome. I know there's some questions and comments coming in. If you want a copy of the slides, I encourage you to reach out to John and Joe directly. Again, we are going to post a recording of this webinar on our website at lift.technology. But I'll leave it up to Joe and John if they want to distribute the slides individually. We also had someone reach out to us, one of our other members over at Mala. If you guys are in need of cooling or heat exchange systems, we can certainly connect you guys as well. Love to see the connectivity between members there. So question about how much, go ahead.
No, Mala people, give me a call.
Yeah,
I'm the geeky one.
We'll certainly make sure you guys are connected level when our members can get together and reach out to each other. So how much driving time do you need to fully charge a system? That may depend on a truck or a that may vary, but is there a way to ballpark that?
Well, assuming my microphone's still on, our primary use is as a plug-in. Our primary customers park overnight and fully charge overnight. That can take 4 or 5 hours. We're more of a sustaining hybrid when we're driving. I showed you the V chart. We have enough energy in general to work through the whole workday, so we don't, unless the customer needs it, do a lot of charge while driving. Our battery's full up. It's almost like a tank of gas, and we size it 1 or 2 batteries to provide a work day. So we don't really fill back up during the workday, but we go on to a maintenance. We do opportunity regenerative charging and things like that. And if we do run out of battery at the job site, we turn the diesel back on, and in about 20 minutes, we fill the batteries up about a quarter of the way, because we don't want to use all that gas to fill it up and the day's over. In about 20 minutes, generally, a typical bucket will get 2 more hours of all electric driving. And that's why even non-plug-in, we're about 10 times better than a non-electrified stationary work truck. There's a short, heavy load for the engine, which it likes, and then go back to electric. Does that answer the question?
I think it does. Thank you very much for that. A couple other questions came in about which material is in use in the drive shaft, and if your batteries have a built-in drain down system. Take those one at a time.
We use a dampened Spicer drive shaft, steel right now, I guess. I'm not down into the details, but it's pretty much an off-the-shelf commercial drive shaft, although we do the dampened. And what was the second question?
Do your batteries have a built-in drain down?
I guess
I wonder if that's related to, maybe that question is quickly discharging the battery, and key off and all that. I mean, we do that through our HVJ.
Our electrical system, if turned off, has self-discharge to below 50 volts in about 2.5 seconds net.
Yeah, and we have high voltage interlock loop and a variety of different, safety diagnostics for safe operation.
The recommended practice for below 50 volts is less than 5 seconds. We're at about 2.5. And all finger safe connectors and HVIL, as Joe was saying.
Yeah.
Excellent. Again, if you have specific questions or want to get more into the details, can certainly reach out to these guys directly. You see their contact information on the screen still, so please give them a shout out. Interesting question here. I don't know how you guys deal with this actually, but there's probably going to be there is I'd assume a knowledge gap or experience gap that the OEMs or dealership sales service, etc. They don't know enough about this technology. How is that? How do you guys work to address that in terms of just the knowledge base that exists with the OEM sales, parts and service that's out there?
So we have training programs set up. We have detailed service training available for our providers. So we get into that. And then there's a lot of education. So basically, in some respects, it's a little bit of train the trainer, right? So we try to train some of the most capable people at these organizations, and then they help train those that work with them. So it is a challenge without a doubt, because this is new technology. But then again, the beauty of it is that the engine, the transmission, they remain under warranty, unmodified. We just use the power takeoff, which is used hundreds of thousands of times. Millions of power takeoffs are out there. So a lot of the components are common. The electrification is different, and we have training for that.
Excellent, excellent. You mentioned you plug in overnight. How many amps do you guys do you charge at overnight?
So it-
Sorry, I think in kilowatts.
maybe we just state, yeah, the kilowatts might be.
We're running 3.3 right now, and we're going to be bumping it up to 6. It's all our customers ever needed.
Okay.
We haven't had a high pull for fast charging. Our customers have been satisfied with the reason we're going higher in our charging power is because with the battery evolutions, our batteries are able to get bigger for some of the biggest solutions. And it's capacity divided by power is time. And so as our batteries get bigger, we have to go up in the power we can push. But we're generally running the SAE J1772 compliant level 1 or level 2 charging. Recommend level 2 for most of our industrial customers.
All right. And again, if you have more specific questions, please reach out to these guys directly through the contact information you have on your screen. I think we have time for one more question, and this is interesting because we didn't. I don't think we saw it on your screen in terms of where you were going, but any future use for fire engines or vehicles of that sort with the ladders and needs that those guys might have.
Yeah, that is an interesting market, one that we do have on our roadmap. Some of the things with that, you have to pick your application carefully. So we can run hydraulics on the aerial or the fire apparatus. We can do the idle reduction. We can export the power. We can heat and cool the cab. One thing that we are not on our roadmap is powering a 400 or 500 horsepower water pump. So we don't anticipate that we'll be doing that. But a lot of times, a lot of these trucks will, they'll even go to false alarms like 50% of the time. So I think there's a big market for our type of technology, including the improved acceleration that's available when you are going to the scene.
Awesome. Well, thank you. I think we're running out of time, so I do want to thank you guys while we're here. Thank you very much for the presentation. Thank you very much, everyone, for joining again. Reach out to these guys direct with any additional questions. We will post this webinar on our website over the weekend and next couple of days here. John and Joe, appreciate you guys pinch hitting for each other while John had some audio issues. Glad we were able to work through those. So awesome. Thank you very much for your membership. Thank you very much for your working with us, and thank you very much for the presentation. Stay tuned, everyone, to your emails for our next month's webinars. We'll be coming back to you in October with we mentioned Mala. They will be discussing some of their work in October, and we'll also be talking to Eris and some of the composite work they are doing with Humvee seats. So thank you very much, everyone. Joe and John, appreciate you, and we'll see you guys next time.
Yep. Thanks, everyone.
Appreciate it.
Thank you.